Good afternoon, everyone. My name is Chuck Bosnos. I'm here with Chris Campbell. Chris and I are both on the sales side of Universal. Chris runs our sales engineering group, and I'm in a business development role. And what we would like to do today is to give you an introduction to Universal Laser, what we do, and how we're teaming up with Cimetrix and Javelin. So that's the purpose of this. And you're going to see a lot of images. And what we want to do is just give you a pictorial review of what we're doing. So these are topics that we're going to cover, and we'll give you kind of an overview of the systems that we build and also the kind of processing that we achieve with lasers that we call digital laser materials processing. So now, with regard to the relationship of Universal and Cimetrix and Javelin, Cimetrix and Javelin, as we understand, they're highly regarded for the company's expertise in modeling, 3D printing, rapid prototyping, SolidWorks, and presence throughout Canada to respond to customer demand. Meanwhile, Universal Laser, we're in the business of laser materials processing technology. It seemed like a very natural thing for our two companies to work together. And what Universal adds is another way to process materials and develop products. So we'd like to show you a little bit about that. Now, Universal has been in business now for 30 years. We're a global supplier of CO2 lasers at various power levels and also complete laser solutions. And you're going to see that we have laser machines ranging from desktop size up to large area. And the machines and lasers are all manufactured here at our headquarters in Scottsdale, Arizona. We also have offices in Europe and Japan. We're going to show you kind of a perspective of our customers, but suffice to say they range from very small business up to Fortune 500 customers. And what's common for all of these customers is what Universal does for them. We build technology that allows people to be very creative and responsive. And in a manufacturing and technical environment, we think in terms of enabling rapid product development, optimizing manufacturing processes for efficiency and quality. In a more creative role, you'll see these machines can do amazing things on a whole host of materials, so it's very easy to be creative with them. So now you're going to see kind of a cross-section of some of our customers. We have customers in aerospace, automotive, medical devices, a range of different categories. So here in an aerospace environment, we do things from marking on individual parts to putting labeling on a complete control panel. So small to large. Here in automotive, this is just one example of a cross-section of applications, but here we're showing different gaskets that we can produce. You'll see a range of materials there. And materials is a theme that we'll bring up through this presentation, because Universal, although we're an equipment manufacturer, we realize that what we're providing is a way to process your materials, and we want to understand those materials very well. So you'll see a little bit more about that later. Here in an electronics environment, we process tapes, gap pads, shielding materials, bonding films, adhesives. We also mark components. So there's quite a range of applications there. This is showing some examples of medical devices. And on the left, you see the white piece is actually made out of Teflon, and we've drilled some holes and cut the shape. And you can see from the 2 millimeter mark there that the holes there are quite small. And one of the things about lasers is they're extremely precise. And to the right, you see a fluidic channel structure that's been etched onto a piece of acrylic. So this would be for sort of a lab on a slide for medical analytics. And the channels have to be very precisely etched to a depth and to a width so that fluid will flow in a controlled manner. Now here's something completely different. Rice University has one of our lasers, and they're using a CO2 laser on Kapton material to create graphene. And the way they're doing this is moving the laser beam across the surface and texturing the surface with a carbon compound that is actually graphene. Very innovative, and it allows them to build graphene circuits in whatever shapes they want. They're using them for all kinds of different things. So higher education is another one of our major market sectors. And here you see another example, this actually from Stanford, where students are building autonomously controlled aircraft. So the job is create an airplane basically that has its own controls built in. And of course, the major challenge for them, well, there are two major challenges. They have to create a control system, but they also have to make an airplane that's going to fly. And you can see their laser shop where they're typically cutting wood to build the models or the aircraft. Now, then we also have a lot of customers in what we call the commercial space. So these people are doing what you might say are decorative applications. So here you see a sign that's been cut out of plastic materials, and you see a leather cell phone case that's been personalized, and you see a piece of wood, and that's actually a pretty large piece of wood. It's about 2 feet wide that has a photo image engraved upon it. So along with having a tool that does very technical things like cutting and engraving and ablating, we also do photo imaging, personalization, decorating of various kinds. So now I'd like to give you just a view to the products that Universal builds. So we have a range of what we call our product families, and these are what you might call the machines. So I mentioned earlier desktop up to large. So the one on the left is called the VLS desktop system, and it is literally something that would fit on a table, although here we're showing it on top of a filter unit. Then we have graduated in sizes. We go up to 2 feet by 4 feet of addressable area. And as we go from left to right, we also move up in terms of capability and flexibility. So we have desktop machines that run a single wavelength of laser. And then over to the right, we have Ultra and XLS machines that can run 2 or 3 wavelengths of laser at the same time. And we would explain the purpose behind that when we get involved in applications with customers. But this gives you a range. These machines are in sort of the teens, $15,000 or $13,000 range up to a few $100,000 range, depending on what is required. Now, Universal, we're a laser company, and we actually build CO2 lasers here as well as systems. So here you see a range of laser, what we call laser cartridges. And the one at the very top is a 250 watt CO2 laser. The ones on the bottom range from 10 watts up to 75 watts. We also build them in, we also have a fiber laser, and we build CO2 lasers in 2 wavelengths, 9.3 and 10.6 micron. And what's nice about the Universal concept is that you can match lasers to the application, and any of these lasers will fit on any, well, within certain limits on any of our machines. Some of the bigger lasers don't fit on the smallest machines, but mid-range to large systems, we can put 75 watts, 50 watts, 30 watts, whatever we might need. Now, all the systems that Universal builds have a common architecture. And what you're seeing in this slide is in the back, item number 6 is actually a CO2 laser. And shown as a red beam, we're showing the beam path to a lens carriage labeled item number 2. And that can move in an XY transport across a work surface. So we have X motion and Y motion, and we can direct the beam anywhere over a field of view. And item number 8 would be the workpiece. So by adjusting how we deliver the laser beam, we can run many different processes. We can cut through material, we can mark on material, we can ablate or engrave into materials. It's all adjustable. So now let's take a look at digital laser material processing. So we've used that terminology to kind of put a wrapper around what it is we're actually providing for people. So I'm going to show you some samples of different processes. And here we see cutting. So this is on a piece of acrylic, and it's about 1/2 millimeter thick. And if you can envision a thin piece of acrylic and imagine how you might be able to cut a shape like what you see, where basically we've created a honeycomb in the acrylic. Well, one of the nice things about laser cutting is it's extremely precise, and it doesn't put any pressure on the workpiece. So we deliver energy accurately, we control its location, and we don't put pressure on the workpiece, so we can do incredibly complex shapes like what you see here. Now here, the next one, we're showing engraving in a piece of Teflon. So you see the serial number and also the channel around it. And sometimes we call this engraving, sometimes we call it ablation. Essentially, the beam is removing material from the surface. And on our next slide, we're showing what we call marking. And in this case, on a piece of Delrin acetyl material, we used a fiber laser to change the color. So in this case, we're not removing material, we're just changing the color. So that is another capability. Now, as we're running these processes, we use the laser beam in different ways. So on the left, you'll see a piece of foam rubber. It actually did, it was cut, the shape was cut, but I want to address, I want to address the imaging. That imaging where we've engraved ULS and the logo and a photo image, that's all done with raster motion, where the beam moves from left to right, kind of like an inkjet printer. And then on the right, you see some Kapton film. This is a polyimide film, thin material, and we did vector cutting on this. So all the holes that were cut and the outline shape was done by moving the laser beam in a vector path. And our control system allows you to do both, either or both, in a single job. So we can do raster imaging and vector cutting all in one pass through the machine. Now, you might think about how you create parts on a laser. It's basically a design to part workflow. So you may be working in a CAD program or a graphics program, and you can either print your file or export your file directly to the laser. So you do your design and you move the job to the laser. Actually, your computer becomes the controller and it runs the laser system as the laser's operating. Here you're seeing a kind of category view of the materials that we process. So ranging from literally paper, numerous organic materials, etching or marking on glass and ceramics, marking on metals, cutting wood materials, a whole range of different categories. And what Universal has created, and this is something that's distinct to ULS, we've created what's called an intelligent materials database. And what this does is it offers customers a complete library of what you might call presets or profiles. So here you're seeing converter materials, and we have profiles for each of these materials. And to us, a profile means the right laser pulsing, the right power level, whether or not we need to put some air on the surface to control the cut quality. We have something like 20 different parameters that we can adjust. And all of that is done by our engineers in our Advanced Materials Processing Center to create a database that's available to you, the customer. So what we deliver, in addition to a highly capable machine, is an easy way to manage the settings so that you don't have to do a lot of experimenting just to get an initial result. So the Intelligent Materials Database is a very key part of what Universal delivers that makes these machines so versatile. Now, what I'm going to show you here are some traditional examples of what lasers do. Here we're looking at glass and ceramic where we're etching. And we're not cutting through these materials, we're just etching the surface. Here we are doing wood cutting. So the lampshade has been cut, the dinosaur was cut. There's also a photo image on wood. And if you look over to the right, you're seeing that we can actually sculpt the surface. You're seeing a 3D contour. And in the case of a laser, that's done by removing material to different depths. So part of our control structure is that we can control the laser pulse energy to be either light for shallow or heavy for deep. And all of this is done in real time as the laser beam moves across the surface. So we create that part in a single pass with a 3D sculpting. Here we're marking on brick and stone. And typically on stone or a ceramic, we're going to have contrast by shading. Although in the case of the brick, we actually create kind of a glass by putting a lot of power on the brick and heating it up to a very high temperature. Here we're cutting on paper. So this is something interesting because you can see the incredible complexity of what can be done. And bear in mind that the laser we use to cut this paper might also, at a higher power level, cut through 3/8 of an inch of solid plastic. So its power is very controllable. And we also have different lenses that we can use for different laser spot sizes to give us different levels of detail. So even to the extent of creating that paper model, if you will, of a fly, we can do incredible detail. Here you're seeing rubber, and you see a rubber stamp down near the penny that's been engraved with one of our special optics for very, very small character size. You're also seeing some gaskets that have been laser cut. Here we're etching or engraving or marking on textile. We're also doing some cutting. This can also extend to industrial textiles, medical devices, leather, all kinds of different textiles. Again, a laser is very controllable. So simply by adjusting how much power and how we're adjusting the speed, we can go from a light etch to a full cut through all kinds of different materials. Now, I've shown you the traditional materials, but now we'd like to get into some of the technical space. And at this point, I want to hand off to Chris Campbell. And Chris has been involved with some of our high-end, very sophisticated applications, and he's worked with a number of these materials. So Chris, can you just give us a few comments on universal capabilities on technical materials?
Absolutely, Chuck. Thank you. On these technical materials, they all have several things in common. To begin with, most of them have small features. They can be thermal management materials, shielding materials, conductive or insulative materials. But the one common thread for these requirements is the need for very clean processed edges and features that hold a very high degree of accuracy and precision. In order to process these properly, what we do is we've got two sets of variables that we have to take into consideration. One of them is the material variables themselves, and those variables are largely fixed and dependent upon physics and the material type. And so in order to process these properly, what we have to do is we build our systems in a modular fashion, which allows us to control the system variables. And as Chuck mentioned, there are quite a few of them. They range anywhere from wavelength to pulse power, pulse duration, things along the line of frequency of pulsing and speed of the laser system. But we put all of these things together along with some unique capabilities like camera registration and some very high tolerance things like air bearings to deliver something that can really produce a very accurate and precise both system movement and pulsing of the laser, which allows us to really produce some very highly technical material products. As an example here, you can see Kapton. This is a very difficult material to process with lasers, the polyimide material. The reason why it's difficult to process is it's a high temperature, thin film material, and it tends to react. Its particular mechanism of reacting is a carbonization that happens. And we've got a few different things in our modular assemblies that allow us to process this in a way that's superior to other laser systems that are on the market. We get into things like the PORON material, which is a microcellular polyurethane foam. This material processes very well with the laser, and the traditional method of processing this material would be a die cut. And when you're die cutting this material, it tends to compress and deflect. And that creates uneven edges, and it can really throw things out of tolerance. We get kind of a scalloped edge to this when we die cut it. So when we're processing this type of material, foam material on the laser, we get a much straighter edge and more accurate cut. You can see here, this is a micrograph just showing the edge of this this processed material. As you can see, it's very microcellular in its structure, but we're holding a very tight edge tolerance or heat effect here of 70 microns, which is really just under 0.003 of an inch. Very small, smaller than a human hair.
Chris, I'd like to just interject something here. We're showing you this image to let you know this is the kind of analytical technology that Universal uses. So we do micrographs, we have a CMM for measuring. So if you have a high precision application, we're a company that understands it from the material standpoint and also how to measure. And when we're running application studies, this is typical of what we do.
I wanted to point out in all of this that we were open to a conversation with you, and if you have particular questions about your materials, we would very much like to speak with you about that. Of course, we worked through Javelin there, and this membrane switch spacer is a good example of another difficult material. What we find with adhesives like this is, again, if you try and cut this with a knife or with a die cut, you end up with getting gummy material on the cut surface, and you end up with a lot of process constraints. Whereas the laser, because it's non-contact, processes this material very cleanly and well. And again, here's another material. It's a 3M material. We've got a lot of 3M materials in our database. This particular material is also difficult to cut in any other way because it's got some nubs that actually stick up off the surface, and those get deformed if they're run in a punch press. And it's a very difficult material to process with a drag knife as well. So the laser ends up being a perfect mechanism to process this material. And again, looking at PET film, we can do cutting and marking on a lot of different thin films. And the value with something like a PET film is that we can also mark on this material very clearly with the wavelengths that we use. So you can process a part and put a part number on it, serialize it all in one process.
Yes, and I would also like to add here, you can envision that with something like this, you can prototype on the actual material and then scale it to production. So the very same laser that does the prototyping might be the model that would be used in production. Or even if you have one of our smaller systems and you need to run lots and lots of PET film, you can scale from a smaller laser to a larger laser very easily because the process is the same. So this is something that is a very good thing with laser technology when you're doing design kind of validation, prototyping, testing. You test on the material that you're going to use.
And again, looking at a VHB adhesive and also an extreme sealing tape here, the materials are very sticky, and they present a problem cutting in actually just about any other way other than laser processing. So with the 3M people, we seem to be very popular because most of their materials are, as they would say, either scratchy or sticky.
Okay. So here you see Chris has given us kind of an overview of some of the unusual materials that we run across. And from the standpoint of what benefits lasers present, you've seen that with some very difficult materials, a laser cuts them cleanly because we're not putting pressure on the material. There's no tool wear, there's no stickiness or gum collecting on it, something like a die. Another thing is because we're not deflecting the material, it's easier to be more accurate with our cutting or even marking processes. And over on the right-hand side, you see that we can do, it's on demand, completely flexible. Whatever shape you want to cut or mark, you can do it. And then seamless ramp, in other words, design in your prototyping lab, move the process to the production floor to actually run. Now, Cimetrix also asked us to give you a little bit of a view to what makes Universal unique or some of the innovations. So we're just going to give you a few because there are a lot of them and we're going to be out of time. But this is called SuperSpeed. And remember raster engraving where we're imaging over a surface. With SuperSpeed, we do it twice as fast. And that's the benefit. We use two lasers, we pulse them at the same time, we create two lines of information. This is patented technology invented here roughly 12 years ago. Then we have HPDFO. When you talk to laser people, they always think in terms of energy density and spot size. And this is a patented design that delivers a very tiny spot with CO2 laser that no one else has ever come close to matching. This slide, excuse me, shows triple wavelength technology on our newest equipment, XLS and Ultra. We call this MultiWave hybrid, where we can actually run 3 wavelengths of laser through one lens, deliver it all to one point, all beams in focus at the same place. This again is patented technology. It enables us to do special things with lasers where we need multiple wavelengths. Then Chris mentioned some of our enhancements, and one of them is camera recognition and alignment. When we need to be accurate, we can use a camera both to measure and also to align. Our systems also have what's called path planning, which means that the control system can look ahead to deliver the best combination of motion and pulse energy. We have curve compensation for people who need to do highly accurate cutting. From a safety standpoint, our machines can be run either as Class 1 fully enclosed or Class 4 open. And we know what those terms mean, and we understand the safety implications, and we give customers advice on that. We also have fire suppression on our XLS systems. So these are just some examples of how Universal develops sophisticated solutions to match requirements. So now we're kind of at the end of our session here. And to kind of wrap it all up, this is a company that's been in business 30 years. We've shipped tens of thousands of lasers around the world. Universal builds systems and CO2 lasers, and all the engineering and manufacturing is done here. So the mechanical design, electrical design, software design, the laser physics, it's all under one roof, and we deliver complete solutions. And when you look at what customers say, one thing that's evident is they keep their lasers for a very long time. It's not uncommon to see lasers that have been out there for 15 years and they're still running. Another other thing that we hear is that because of things like the materials database and some of the particular solutions we offer, our machines are accurate, processes are reliable and easy to manage, and the machines themselves are easy to use. So what we'd like to encourage you to do is think about how laser might fit in your environment. Get a hold of James at Cimetrix, or you can always contact us here directly at Universal, and we'll be happy to help you. Our objective will be to help you understand how a laser might help you, and we'll do our best to give you the information you need. And with that, I think we're ready to wrap up.
Joseph, it's James here. Excuse me. Thanks, Chuck. Thanks, Chris. That's a lot of great info and quite condensed into that half hour. So if there's any questions, please feel free to type them in, and we can also follow up with a telephone conversation if you do not have the time to allot it to stay on this webinar a little longer. Just wanted to note that we do have a laser at the Oshawa facility, and we are able to process materials there. And we are open to visits if you want to see how the equipment works and what the processes involves. You're welcome to do so. Hey, Chuck, so we can just hang on a bit if you'd like to make any additional comments. You have a few minutes left.
Sure. One thing I would be very interested in, even if it's not framed as a question, is what kinds of materials some of the attendees are working with. Often when we have an initial conversation with a customer, the phone call might be something like, hi, I'm interested in a 50-watt laser. I need to cut my so-and-so. And what we like to do is really explore that with a customer, learn about the materials and not only what they called about, but other things that they do as well, because that kind of opens the door to a deeper understanding. And with some of our customers, they may be working with many different kinds of processes and materials. So we're always interested in that. Another thing I would say is just to go back to the workflow, remembering that you can design to part. So you have a design, you export the file, the laser makes the actual part, which enables you to be very productive in a development environment, and of course also in a production environment. Another thing I'm curious about is whether attendees actually have lasers, whether they might be laser welders, cutters, soldering lasers, who knows what, but I'm just curious about what experience people have with them.
Right. If you have any questions, you can contact myself, James Garfield at Javelin, at Cimetrix division of Javelin, or anybody else. We probably will follow up with some sort of email or phone call after this webinar. Oh, thank you everybody for attending, and thanks Chuck and Chris. Okay. Let's call it a day.
All right, thank you very much. We appreciate your time and attention. Thank you, and thank you, James, for setting up this webinar.
Cool, thanks. Talk to you soon.